In this example, we have two charges that are separated by 3 centimeters. Charge A has a charge of positive 6 microcoulombs. That's what that little symbol means. It's a Greek letter. While charge B has a charge of 3 microcoulombs. What's the force on charge A? Now we know because of Newton's third law that the force on charge A is equal but opposite to the force on charge B. So we're finding both, really. But we're going to talk about, when we talk about direction, we're going to talk about charge A. Let's list what we know. The distance between these two is 3 centimeters. And hopefully we see right away that that's not SI units. And we have to do a conversion to get it from centimeters to meters. And if you can remember our King Henry died Monday drinking chocolate milk, we're at centimeters and we want to go to meters. So we go 1, 2 to the left. So if we move our decimal 2 to the left, we get this. We have to leave that 0 so that it has the same number of significant figures. Next we have the Q1, charge 1, or you can say A if you want, since this isn't A and B's. It's positive 6.0 microcoulombs. You know that microcoulombs aren't the SI unit, so we have to convert it, but you might look at this and go, there's no micro on here. There's milli, but micro is even smaller. I will just tell you that micro means times 10 to the negative 6. So we will just take and write positive 6.0 and take off the micro and write times 10 to the negative 6 coulombs. And Q2 is equal to positive 3 microcoulombs, which comes out to 3 times 10 to the negative 6 coulombs. Remember that a charge is very, very small, so it would be understandable that the amount of coulombs in it are very, very small. Our equation for this kind of calculation is force equals K, which is a constant that you're given in your notes, as 9.0 times 10 to the 9th, so this is a very large number, newtons times meters squared divided by coulombs squared. And those are just the units that are required for this to mathematically work out. So we have K times Q1 times Q2 divided by D squared. So if we plug into this equation, and let's look at all the units, and it's okay if in your work you drop the units. I'm just going to show them to you this first time so that you can see how all the units cancel out. I'm going to move the screen over just a little bit. Divided by our distance, and make sure we use the distance in meters. Now we see we have meters squared, we have coulombs squared. Oops, forgot to write it there. And that gives us just newtons, which is what we need. The hardest part of this is putting it into your calculator. So be very careful. Use the EE button if you have it. If not, make sure you put your scientific notations in parentheses just to be careful. And when we get this and we round it to the 2 significant figures, we get that the force is 180 newtons. And if we're talking about the force on A, it's going to be away from charge B because charge B is also positively charged. So like charges repel. If we asked about the force on charge B, we would say 180 newtons away from charge A, so in the opposite direction.